All right, so the whole large language model ecosystem, right? It can feel like you're staring at this huge, uncharted territory. But what if you had a map? Well, that's exactly what we're going to do today. We're going to turn all that complexity into a super clear, navigable path. That way, you can go out and build with total confidence. So, let's dive.
So, does this sound familiar to you? You get a ticket dropped in your lap. Something like, hey, integrate some AI to summarize user feedback. And look, you're a great engineer, you know your stuff, but this whole LLM world, it's huge. Where do you even start? Which model do you pick? Which API do you call? Should you run it locally, in the cloud? It's a classic problem, and honestly, we're gonna break it all down, step by step.
Okay, so here's our game plan. First up, we'll talk about choosing your model's breed. Then we'll get into the big debate, frontier versus open source. After that, we'll cover how you actually connect your app to a model. We'll even touch on running LLMs locally. And to wrap it all up, we'll give you a solid engineering playbook you can use. All right, let's jump right into part one, choosing your model's breed. Think of this as the absolute foundation of your AI feature. Before you even think about writing a single line of code, you've got to make this call. And trust me, getting this right from the start is going to save you so many headaches down the line.
So you've basically got two main families here. On one side, you have the base model. I like to think of this as a brilliant but kinda unfocused intern. It's packed with raw knowledge, but it hasn't really been trained to follow specific instructions. It's creative for sure, but unpredictable. Then you have the instruction or chat model. This is the one that's gone through some serious training. We're talking about things like supervised fine-tuning, or SFT, where it's shown thousands and thousands of examples of what to do. And also RLHF, that's reinforcement learning from human feedback, where actual people help shape its responses to be more helpful and safe. This is more like your reliable senior engineer. It's ready for production, and honestly, for most of the apps you're going to build, this is the one you'll want.
But what if your task is a bit more complicated than just a simple chat or a summary? What if you need to actually analyze some complex data, or solve a multi-step logic puzzle, or plan out a whole sequence of actions? Well, that's where reasoning models come into play. These are a totally different beast, a more advanced, specialized breed of model that's really designed for that kind of heavy lifting. So how do they actually pull this off? It's pretty cool, actually. Instead of just spitting on an answer, a reasoning model uses what we call a chain of thought process. You can literally think of it as its own internal monologue. It breaks the problem down into smaller pieces, it verifies its own assumptions, it checks its work as it goes, and it even corrects itself. Kind of like we do. This whole process is the secret sauce behind their incredible accuracy on those really tough, complex problems. Okay, great. So you've picked your model's breed. Now you're at the next major fork in the road. And this is a big one. Do you go with a top-of-the-line commercial model, or do you grab an open-source alternative and run with it? This is that classic engineering trade-off, right? Ultimate power versus total control. So on one side of the ring, you've got the frontier models. We're talking about the absolute state-of-the-art, the bleeding-edge stuff from the big labs, OpenAI, Anthropic, Google. These are, without a doubt, the most powerful reasoning engines on the planet today. But there's a catch, and it's a big one. You can only get to them through an API. You can't download them, you can't peek under the hood. It's a black box. So yeah, it's all about the trade-offs. What you get is absolutely best-in-class performance. The reasoning, the safety, the reliability, it's all there right out of the box. But what you give up is a lot. You give up transparency, you can't fine-tune the model on your own data, and you're completely at the mercy of their pricing and their uptime. Now, if you're building a high-stakes app where accuracy is just non-negotiable, this is often the way to go. And then, on the other side, you've got the open-source world. You've got amazing models coming from places like Meta, with their Llama series and Mistral. And with these, the story is completely different. They are totally open, you can download the weights, you can tweak them, you can fine-tune them on your own private data, and you can run them on your own servers. You are in complete 100% control. And the benefits here are huge, right? First off, data privacy. Your data never leaves your servers. That is massive. Over the long run, the cost can be way lower and the flexibility is just off the charts. So what's the catch? Well, the raw reasoning power, while it's getting better at a frankly insane pace, still tends to be a step behind the absolute top-tier frontier models. And they just require more engineering love to get them deployed and keep them running smoothly. All right, moving on. You've picked your breed, you've chosen your source, frontier or open. Now for the next piece of the puzzle. How does your application actually talk to the model? This might sound like a small detail, but it's a huge architectural decision that impacts the resilience and flexibility of your entire future. So you've really got two main paths you can take here. The simplest path, a direct API call. You just point your code straight at, say, OpenAI's API. It's super fast to get started, but you're creating some serious vendor lock-in. And if their API has a bad day, your feature is toast. The more professional approach, especially for production systems, is to use an orchestration layer. The best way to think about this is like a smart router. It's a middleman that sits between your app and all the different model providers out there. And here's a perfect example of why this is such a game changer. With an orchestration layer, you can set up automatic fallbacks. So imagine your app tries to call GPT-4o, but for whatever reason, the API is down or timing out. Instead of just failing and showing your user a nasty error message, the orchestration layer just handles it. It can automatically and transparently retry that same request with a backup model, maybe Cloud 3. Boom, you've just built resilience right into the core of your system. And the good news is the tooling for this is already really mature. So if you just want a simple, unified API to talk to a ton of different models, something like OpenRouter is a fantastic choice. If you're building a serious production system and that fallback logic is critical, you'll want to look at Light LLM. And if you're getting into more complex stuff like building multi-step workflows or agents, well, LangChain is pretty much the industry standard. And these tools can do more than just fallbacks. They can handle things like load balancing or even A/B testing different models to see which one is the most cost-effective for a specific task. Okay, but what if you want to sidestep external APIs entirely? For those situations where you need the absolute maximum privacy, total control, and maybe some serious cost savings at scale, you can run these incredibly powerful open source models on your own hardware. And honestly, thanks to an amazing community, running models locally has never been easier. Let's break down the three main tools you'll run into. First, there's LM Studio. This is the absolute easiest way to get started. It's a desktop app, you point, you click, you download models, and you can chat with them. Super simple. Then you have ollama. This one is a huge favorite among developers. It gives you a clean command line tool and, most importantly, an open AI-compatible API server. This makes it perfect for integrating a local model into your application code. And finally, under the hood of a lot of this stuff is llama.cpp. That's the super high-performance C++ engine that actually makes it possible to run these giant models on regular computers. So, to cut right to the chase, here are my quick recommendations. If you're just looking for the easiest way to play around and experiment with different models, just go download LM Studio. Simple. When you're ready to actually integrate a local model into an application you're building, you're going to want to use ollama. In fact, a really common professional workflow is to use LM Studio to test and benchmark a few models, and then once you've picked one, you use ollama to actually serve it in your production environment.
Whew. Okay, we have covered a ton of ground. We've talked model types, providers, different ways to connect, hosting options, the whole shebang. So now, let's tie it all together. Let's distill it down into a simple, repeatable playbook that you can use every single time you start a new AI project.
And here it is, your 4-step engineering playbook. It's really just 4 questions you need to ask yourself. Number 1, select your breed. What kind of job does this model need to do? Is it basic instruction following or heavy-duty reasoning? Number 2, choose your source. Do you need the raw power of a frontier model, or is the control you get with open source more important for this project? Number 3, pick your connection. Is a simple direct API call going to cut it, or do you need the reliability of an orchestration layer? And finally, Number 4, decide on hosting. Does a cloud API make sense, or do your privacy and cost needs mean you should be running this locally? So there you have it. The LLM landscape, it's not some big, scary, unknown territory anymore. You've got the map, you've got the compass, and you've got a clear set of decision points to guide you all the way from that initial idea to a full implementation. So now the only real question left is, what are you going to build next?